Okay, so if you're settling down to watch a video on trig graphs, I am assuming that you are already very comfortable with right-angled trigonometry. You're comfortable with sine rule and cosine rules. You've got a fairly good grasp of your sine, cos and tan functions and uses. Now there are three different curves that you need to remember and learn how to draw. Two of them are very, very similar. So your sine curve and your cosine curve are basically the same curve but moved 90 degrees, translated 90 degrees. So your sine curve is the first one that you think of, and it starts at 0 and oscillates between 1 and -1. And the sine curve is infinite. It goes, keeps repeating its cycle every 360 degrees between -infinity and +infinity. So usually when you're sketching them, you are going to either go between 0 and 360 in steps of 90, or sometimes they'll want some negative angles as well, and then you often go from 180 down to -180. But if we focus on this first of all, for the sine curve, it starts at 0, and then the pattern is that. So it goes from 0, and on the first 90-degree interval it reaches 1 before coming back down to 0, and then 1, -1, sorry, and then back to 360. So the graph that you will be drawing will look like that. Okay, so your stages are in 90s or -90s, and then you start at 0 and it's oscillating between 0, 1 and -1. Now the cos curve is exactly the same. The only difference is the 0 degrees is there. So it does end up looking, so that is sine x, where x is the angle, and that is the value of sine x. For cos, again, what -1 and 1, again we're going 4 equal steps, so 90, 180, 270, 360. But this time the curve doesn't start at 0, it starts at 1, then drops to 90, then to -1, then back up again, and back up to complete the cycle. So with this one, it's essentially the same curve, but it started there and finishing further up there. So what you have to remember is you have to develop a way of remembering which one is which. Now for me, that looks most like a sort of inverted back to front S. So for me, I'm thinking sine is the one that's like an S, starts at 0, whereas the cos one doesn't look as much like an S as that one does. So if you try to remember, or however you choose to remember it, that sine starts at 0, cos starts at 1. The one that's completely different to that is tan, and again I'm just trying to refresh your memory here. I'm not trying to teach you how these are developed. Hopefully that is something that you will have covered in your maths class, but if you do want me to develop that further, if you leave a message on the wall, then I can happily go into why these graphs exist in the way that they do. The tan graph is the one that is the sort of mad cousin of the other two, because we still work in 90 degrees, and tan also starts at 0, But what happens with our friend the tan is that it shoots off to infinity. So at 90 degrees and 180 degrees, our tan graph does this, flies up very, very quickly off the graph, and then it comes back the other side at negative infinity, and then back up again, and then like that, and so on. So that's tan. And again, I could spend an hour explaining to you how those graphs are actually generated, but for the purposes of answering the past paper questions, I'm assuming you already know that. So you just need to be able to remember, if the question says draw a sine graph, how to do it. You know, if it's on a paper 2, you can use your calculator to help you there. It's much easier, but it could be on a paper 1. Just to turn these in the other direction, you could be asked to take it into negative angles. If you do, that pattern continues. So it's going to go from 0 down to -1, and then back up the other side like that. So if it asked you to draw the sine graph between -180 and 180, that's what you would be drawing. And with the cos graph, again, it would be coming down from 1 to 0 there, and then from 0 to -1, and then it would be heading back up again. With the tan graph, the same situation, at -90, -180, there'll be another asymptote there, which is what we use the word asymptote to define when something is sort of flown off to infinity. So you can see here we've got that coming in there, and then that will go there. So you can see it's a repeating cyclical pattern, and we use that pattern and the symmetry of the pattern to answer the questions on the past papers. So the final thing to add now, before we look at the past paper questions, is when the questions say sketch, the only thing you're actually freehand sketching are the curves. So whereas for that little introduction I've freehand drawn the axes will be printed for you, but it's important that you are making these tick marks on your graph equally spaced. So you'd use your ruler to mark those, whereas I've done them by eye on that little introduction. Okay, so let's take a look at some past paper questions. I'll just zoom in a little bit. So with this first one, using the axes below, sketch the graph of y equals sine x for values from -180 to +180. So that again now is one where it isn't going up all the way to 360 here. We're going 90, 180 that side, and -90, -180 that side. So using my ruler, I'm going to make sure that I can fit in 2 tick marks that side. So I'm going to go 2 centimeters and 2 centimeters. That's 90 and 180. And then on this side, to make sure that they're equally spaced, 2 centimeters, 2 centimeters, -90, -180. And I know that sine and cos oscillate between +1 and -1, so I want to make sure that that's nicely spaced as well. So again, I'll go 2 centimeters that side and 2 centimeters that side for -1. Now, this actually is on a calculator allowed paper, so if you're not sure about whether I'm going to start at 1 or 0, all you need to do is put in sine of 0, and the calculator tells you it's 0. If you put cos of 0 in there, which we will later, cos of 0 is 1. So you'll know cos of 0 you'd start at 1. For us it's sine of 0, so we're going to start there. Now 90 is up there, so again I want to try and make the sketch as accurate as possible. So this side of the curve is going to do that. And then on this side of the curve, to complete that cycle, it's going to drop down to -1 there and then back there. So it's usually easier when you're drawing a curve to keep the inside of the curve on the inside of your wrist, because you're forming a natural compass with a pivot on your wrist. So I'm going to do that. So that's my sine curve. So 2 marks for that. You get a mark right for that side, mark right for that side. Now we're now going to be asked to use our graph, and they're giving us here one value that we're looking for. We want to know what value of x makes sine x negative 0.3091. So that value is what we're reading off this axis here. So minus 3.091 is going to be about there. This bit doesn't have to be accurate, and this will become clear in a moment. So what you're wanting to do is to work out what these two angles are. They're the only place that that red line crosses between negative 180 and 180, that graph. Now in order to work out the first value, you use your calculator. So you would say from calculator and to work out x, if you remember from your right angled trig, if you've got sine of x is something, to get the x on its own, you do the inverse of sine, which is sine to the -1, which on your calculator is above the sine button, so you'd be shift sine. So on your calculator, you're going to do inverse sine of minus 0.3091. So here we go, on our calculator, shift sine, sine -1, which is what you see there. Now it's a negative, not a take away, so we use the negative button there. 0.3091, close bracket, so minus 18 degrees. The minus 18 degrees is the first figure off your graph. So it's telling you that that angle there is minus 18 degrees. What you then do is, using the symmetry of that curve, if that distance there is 18, this distance here must be 18 as well. So to get the second missing value from graph, x is going to be 18 degrees in from minus 180. So that's going to be minus 180 plus those 18 degrees there. So we're going to do negative 180 plus, oops, it's gone off the screen, 18 equals minus 162. And then all you need to do, just to make sure that you're right, and again, you know, this isn't, you don't have to do this, but it's good practice to do so, because you know you're going to get the marks then, is just check on calculator. If you do sine of negative 162, you should get something close to minus negative 0.3091. So let's check. Sine of negative 162 equals minus negative 0.3091. So there you go. You know you're right. You know you've got 4 marks for that question. Okay, question 2. Using the axes below, sketch the graph of cos this time for values between 0 and 360. So 4 equal jumps this time, all on the positive side of the x-axis. So let's get see if I can fit in 2 centimeters. 1, 2, 3, 4, just about. 90, 180, 270, 360, and in this direction I'm going 2 centimeters up, 2 centimeters down, 1, negative 1. Cos, just check, cos of 0 equals 1. So it's going to start at 1, it's going to drop to 90, then it goes to negative 1, back to 270, and then back up to positive 1 there. So this graph is going to go down and up and up and then back down the other side like that. So that's your cos graph, 2 marks. Find all the solutions from the following equations. So this time it's plus 0.9. So plus 0.9 is going to be up there somewhere. Go from 0 to 1. So that's going to be 0.92, blah, 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 blah. And then we draw that horizontal line from there right the way across our graph. And you can see it cuts twice. So what we're looking for is that value, which the calculator will give us, and this value over here, which we will use the symmetry of the curve to find out. So from the calculator, x is going to be cos to the minus 1 of 0.9205. So get that on the screen somewhere. Shift cos 0.9205 close bracket equals 23 degrees. So I know that that is 23 degrees. So the distance in from that maximum value there, where it is 1, to there is 23. So this distance in from that maximum value to there is going to be 23. So the angle I'm looking for is going to be 360 less 23. Okay, just check that again. I know that using the symmetry, it's 23 degrees from that value to my chosen value, the value I need. So using the symmetry of that, I'm coming in 23 degrees from that maximum. So it's going to be 360 less 23, which is 337 degrees. And again, we can do a check. Cos of 337, cos 337, 0.920. So it's not exactly the same, but it's good enough to know that I'm right. So I know that I'm right. Okay? Okay, number 3. So with this one, it's cos, so it's the same curve that we drew in the previous question, but now we're not going from 0 to 360, we're going from minus 180 to 180. Again, remember, jumps of 90 degrees. So I'm going to go 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, 90, 180, minus 90 minus 180. 2 centimeters 1, 2 centimeters negative 1. Cos of 0, I remember from the previous question, is 1, so I'm starting at 1, so I'm going to go 1, 0, negative 1, 1, 0, negative 1. So the graph is going to do that. Okay, so there's 2 marks for that, sorted. Find all the solutions for minus 0.8. So minus 0.8 is going to be down there somewhere. So get your graph, your ruler, draw a line across the graph, and you will see that there's going to be one answer over here that I need, and there's going to be one answer over here that I need. Your calculator will give you one of them. You then use the symmetry to work out the other. So from calculator, x is inverse cos to the minus 1 of minus 0.829. So let's see what that tells us. Shift cos negative 0.829 close bracket equals 146 degrees. So the calculator is telling us that one. The symmetry of that shape is telling me that that one is exactly the same as that one, but it's negative. Okay, you've got reflectional symmetry across the y-axis. So from the graph you can see straight away that the other angle is negative 146. From graph, the other angle is minus 146 degrees, and again you can check that. Cos of negative 146 minus 0.829. So we know that we're right. We know we got 4 marks. Okay, then we've got question 4. Now with this one, it's a bit more work because they want us to go 4 stages that way to 360 and 2 stages this way to negative 180. So I've got a bit more of a squeeze on with this particular question. So I'm not going to fit 2 centimeter jumps, so I'm going to go 1 centimeter jumps. So we go 90, 360 that way, and then minus 90, minus 180 that way, and going in this direction I can still get my 1 and minus 1 in. 90, 180, 270, 360, minus 90, minus 180. So it's going to look a bit more squeezed up because of the scale that I've used. I know it's sine, I can remember it starts at 0, it goes up to 1, comes back to 0, down to negative 1, back to 360. And in this direction it's going to drop from 0 to negative 1 and back up again. So that's my graph. So this time I'm going to minus 0.8. So minus 0.8, change the colour of the pen, I've gone wrong here, haven't I? So that, let's say minus 0.8 is roughly there. Now when I draw this in, there are in fact, that one is an intersection, that one that one, and that one. So there are actually 4 answers that I am looking for. The calculator will give me 1. I've got to use the symmetry to work out the other 3. So from calculator, x is inverse sine of negative 0.8. So shift sine negative 0.8, 53 degrees, negative 53 degrees, I'm sorry. So that's that one, between 0 and minus 90. So if that there is minus 53, you've then got to use the symmetry. So that's telling you for this one, it's 53 in from that 0. So it's going to be 53 in from that 0. So it's going to be minus 180 plus 53. And then over here, that one is going to be 180 plus 53. And that one's going to be 360 minus 53. (360 minus 53). So let's work out those. So minus 180 plus 53 minus 127 degrees. So that's that one. 180 plus 53, 233 degrees. That's that one. And 360, oops, less 53 is 307 degrees, which is that one. So once you've drawn your clear sketch, you put your line on, you identify how many times the line crosses the curve, and that's where you go hunting for your solutions. Okay, question 5. Sine minus 180 to 360. So that's another one where we've got to go in smaller steps to fit it on. 1, 2, 3, 4. 1, 2. 90, 180, 270, 360 minus 90 minus 180, 1 minus 1. Okay, it's sine again, so it starts at 0, rises to 1, drops to 0, down to minus 1, back. That's that side. Drops from 0 to negative 1 and back to 0 again. Negative 0.7 is going to be down here somewhere. Draw your line. And again with this one, we've got 4 angles that we need to calculate. And in effect they're the same ones, or the same symmetry as in the previous question. They're going to be different values because that's different. From calculator, x is inverse sine minus 45 degrees. And then from the graph, that's the minus 45, so that's going to be 180, bringing in 45 degrees. You're going to add 45 degrees to it. That one's going to be 45 on from 180. that one's going to be 45 in from 360. So from graph, x is minus 180 plus 45, which is that one. X is, we know that one, that's the negative 45 one there. X is 180 plus 45, and x is 360 less 45. So minus 180 plus 45 minus 135, 180 plus 45, 225, and 360 minus 45, 315 degrees. So hopefully you can see these now are quite repetitive in style. Question 6. Okay, so this is a curveball. This is your unusual one for tan, the one that flies off to infinity. So again, we're going from 0 to 180 and 0 to minus 180. And we have these infinity points, asymptotes as we call them, at 90 and minus 90. So the graph starts at 0, whips up to infinity, and then comes back down the other side from minus infinity and up to 180, and you can see the symmetry of the pattern, what happens that side. So it's going to look like that. So that's a totally different graph that you have to remember, but for this part it's the same thing. We're going minus 14.3, well, minus 14.3 you know, is down here somewhere. Don't really know where on the scale of things, but let's say it's there, so that's minus 14.3. Draw your line across. You're going to have one value that side, negative, one value this side. Your calculator will tell you one of those. So from calculator, x is inverse tan of minus 14.3, shift tan minus 14.3 minus 86 degrees. So that's telling us that one. So this one, from the symmetry, the 86 degrees is coming from the 0 point, so that distance there is 86 degrees, so it's going to be 180 less 86 degrees. So from graph, x is 180 less 86, which is 94 degrees. We haven't done a tan before, so let's just check that. So tan of 94 degrees minus 14.3, which is what we want. So although that's what I'm less familiar with, because we haven't done that many of them, I know I've got it right because I've checked it. Okay, and then the final two questions are taken off non-calculator papers. So this is where you need to recognize and memorize what the graph looks like. So sketches of 3 graphs labeled A, B and C is shown below. Complete the following table matching each function with appropriate graph. Right, so if you remember at the start I said sine looks like an S, and to me there's an S. That doesn't look like an S, so that's my sine graph. Tan is bonkers, it's the one that shoots off to infinity. So tan is B, and A is cos, where it starts at 1. So you do need to be able to recognize the graphs. And then the final question, on a non-calculator paper, sketch the graph of cos, so that's the same as if it was on a calculator or a non-calculator. So we can just about fit 2 centimeters on this. Remember, this paper will be twice the size when you're sitting in an exam, so you'll have more room. And in this direction, we'll go up 1.5 and down 1.5 to plus 1 and minus 1. Cos starts at 1, drops to 0, down to negative 1, 0, negative 1. Looks a bit wonky, but it'll do, it's good enough. Write down the values of cos of 0. Cos of 0, x is 0, cos is 1. Cos of 90, 0. Given that cos 75 is 0.2588, write down a value of angle A for which cos of A is negative 0.2588. Well, because this is completely symmetrical about that curve, if here is, hold on, sorry, so cos of 75 is 0.2588, so 0.2588, you know, is going to be kind of there. And that is 75. Then minus 0.2588, which is there, is either that one or that one, and you could give either of those. But hopefully what you'll see there is that, again, because of the symmetry, if that distance there, if that distance there is 75, this distance in here is 15. So this distance here is 15. So that, for that value, you're going to have 90 plus another 15, which is 105 degrees. So that one's a bit trickier because it's this that's changing from plus to minus, not the other. But essentially it's the same idea. You're using the graph and the symmetry of the graph in order to work out what your answer is. So hopefully you'll find that helpful.